Okay, so I hope you are able to get Git running. And again, so you might have gotten Git installed on your computer, and the way you can check to see if Git is installed, you just type in git -- version, and if you get something that says Git version whatever, then that means you have Git installed on your computer. So open up a terminal window, PowerShell window, wherever, and if you type in git -- version, you'll have it. If on Windows, I recommend running git bash. PowerShell is also great, but that's a way for you to check to see if Git is installed. Now, your Git commands only work in a Git repository, and so again, to get a Git repository on your computer, I highly recommend first creating your repository on GitHub and then cloning that repository from GitHub onto your own computer. And so in your account, I told you to create a fork, okay? Create a fork of my repository. And it looks like some of you have done it, okay? I can see 38 forks have been created, but that means probably close to 40 of you have not created a fork of this repository yet, okay? So if there are 80 of you enrolled in the class, there should be 80 forks of this repository, okay? So you will go to create an account on GitHub, you will navigate to my repository, which will be SmilesChen 2024-FA-Stats21, and you will click this button, fork, okay? And then once you've created a fork, then you will clone your forked repository, using the code here. You will click, you'll find the SSH key. Okay, so right now, I'm not signed in. That's what's going on. So if you're signed in, you'll have an SSH key option. All right. So again, here's my repository, which has been forked. It will, on your account, it will say forked from SmilesChen, and this will be your thing. And then under code, you will find SSH. You will copy that, and then in your terminal, you will do git clone, and then you'll paste that. Oops. You'll paste the. I guess I didn't copy it. So you'll do git clone. Again, I've already done it on my computer. If you've already done it, don't clone it again. All right. So on my computer, it's a little hard for you to see. I already have the 2024 Fall Stats 21 repository cloned onto my machine. Okay. And then so what I'm going to do is I'm going to change into that folder. All right. And so here I am in my 2024 Fall Stats 21 folder. And then if I type in git status now, then it will say I've got all of this stuff. Now, if I list the contents of my folder, so I did this on Monday, okay? And I cloned it on Monday. So I have basically this reflects the contents of my repository on Monday. So you can see I have lecture 0-1 from week 0 and 1-1 from from Monday. But the professor has added materials. Okay, added basically 5 files to the GitHub repository. Okay, I added 2 files. Related to today's lecture 1-2, okay, along with 2 Python scripts and a .git ignore. And so these have all been added. And so in order to kind of download these things, we need to pull the changes from the professor's repository. So that's going to be the upstream repository. So in Monday's lecture, so you might need to, you don't have to do this right now, but in Monday's lecture, I provided instructions on setting up an upstream repository. And you can check to see if your upstream repository is set up by typing git remote -v. -v will give us the verbose content. And if you have it set up, you will see an origin and you'll see an upstream. If you see the upstream repository, then that means your upstream repository is set up, I believe, okay? And your upstream repository, everybody's should say Smiles Chen. Smiles Chen. Your origin repository should have your own username in there, okay? Your origin will have your username, and then the upstream, everybody will say Smiles Chen, because everybody's upstream repository will be me, the professor, my repository here, okay? And if you don't have your upstream repository set up, you can check Monday's lecture. You'll do, git remote, add upstream, and then you'll put in the address of the upstream repository. So you should you need to have that upstream repository, and then in order to kind of pull the changes from the upstream repository, you're going to do git pull upstream. So you're telling Git that you want to pull the changes from the upstream repository, and you want to pull it from the main branch of the upstream repository. So you're doing git pull upstream repository main branch. That's what we're doing, okay? And when you do this, it goes to the internet and it says, I see there's 5 new files, okay? 5 files changed. We're going to add all of this. And so now, if I look at my directory, if I type in ls to kind of list off the contents, it now has all of the contents of that, okay? And so this is going to be a much more efficient way for me to distribute files to you guys, rather than posting everything on Canvas individually. Because if I post my files on Canvas, then you have to go to Canvas and you have to download each file individually. And then if you accidentally click a file more than once, then you'll get like multiple copies of that file in your downloads folder. And then also your downloads folder is probably just a huge chaotic mess, I imagine, right? There's probably like 2,000 files in there, 18.7 gigabytes of stuff, of different PDFs and CSV files and images and things like that. So this will keep everything kind of contained in this, one repository. This will be a much better way for us to for me to send files out to you guys, okay? So again, the command there is git pull upstream main. Git pull upstream main. That's after you have your upstream repository set, okay? All right, and then so once we have that, then we can discuss a few things. All right, so I'm going to introduce working in Python notebooks, Jupyter and whatnot. And so here I have a document called Setting Up. And I already have Python and Jupyter set up on my computer, so I'm not going to be able to kind of like run this for you guys. And also, I have I have a Windows computer here, and some of you have Macs, and the instructions are a little bit different for these 2 different things. So one thing I strongly recommend is using a program called PyEnv, okay? PyEnvironment. And the reason for this is that Python and basically all of this software stuff and the whole landscape is rapidly changing and evolving. And so, you frequently have to kind of update things. And so I asked ChatGPT, like, can you give me a little paragraph on why PyEnvironment is a useful thing? So let me just read this. It says, Python is an evolving language and different projects may require different versions of Python. And so it says some older projects may rely on an earlier version of Python, while new projects require the latest version, and PyEnvironment and PyEnvironment Windows solves this problem by letting users install and switch between multiple Python versions effortlessly. And instead of overriding the system's default Python installation, it creates isolated environments. So basically, as you work and stuff, okay, right now, like in our class, most of the stuff I cover in this class will just work across kind of all versions of Python. But especially as you get into using different data science specific packages, if you're interested in running kind of like a local version or setting up an LLM, right? So you want to do like some ChatGPT stuff, or Meta has Llama and do like AI-based stuff. You're going to have to kind of install some packages, and these things are kind of on the cutting edge. And what that means is that they get updated frequently. Okay, so like in a couple of weeks, they're going to have a new version out. All right, in a couple of months, a new version gets published. And so as you do these, sometimes the code that worked before no longer works, or whatnot. And so sometimes you want to keep these legacy versions of Python running so you can run these older scripts that you've written. And then as new versions come out, you update those and things like that. And so PyEnvironment is going to help you do that. Okay, so if you're on Mac OS, you're going to install this. If you don't have Homebrew, you'll have to install it. But I think a lot of you probably installed Homebrew during your installation of Git. And then once you have Homebrew installed, you'll do brew install PyEnvironment. You'll have to kind of update your shell startup script. And so most of you on Mac OS, this script will work, but if you're not sure, you might have to just read some of the information on the PyEnvironment website for things specific to that. And then once you have that, then you will install the latest version of Python, and you'll call PyEnvironment install. As of today, the latest version is 3.12.6 of Python. Python 3.12.6. Probably in a few weeks you'll get 3.12.7, and then or maybe not, and then pretty soon 3.13 will be published. Yeah.
You use Conda.
You can use Conda. Yeah. So I used to recommend Conda, but as things are kind of evolving and changing, I've switched to recommending PyEnvironment. But yes, if you already have Conda running, like Miniconda or Anaconda, that's fine. So you can do Conda install, Conda update Python and things like that. Okay, if you're on a Windows machine, your commands will be very similar but a little bit different, and you'll install Python that way. Okay. I don't have time to kind of go through everybody's, if you're experiencing trouble right now, I don't have time to kind of troubleshoot right now, but come to office hours, all right? If you're having trouble getting your Python installed on your machine and things like that, bring your computer to office hours, and I'm happy to kind of work with you. And then, if you can't come to office hours in person, you can sign in on Zoom, and then I'll ask for remote control support. And then and I can help you as well, okay? And then once you have Python installed, then the next thing you'll want to install is support for Jupyter and Notebook and Jupyter Lab. So Jupyter basically allows you to create these notebooks, okay? So in Python, you can frequently write scripts. In a script, everything is expected to be Python code. A notebook is going to consist of a mixture of cells of text and code. And so a Jupyter notebook, Jupyter actually supports multiple languages, Julia, Python, and R. And that's where the name Jupyter comes from, Julia, Python, and R. But it organizes information in cells. And so some of those cells will be text, where you can kind of put in commentary and headings and bulleted lists and things like that. And then other cells will be code, where you can kind of run code. And it's especially useful for, say, data science or data analytics, where you will want to run some code, produce a visualization, then you'll want to talk about it. Okay, and so Notebook is ideally suited for that. And so to get that running, you're going to use the package manager pip, and you can do pip install Jupyter Lab and Notebook. So these are basically, you're listing out the different things in there. So you'll do pip install there. Yeah, again, if you have Conda on your machine, you can do Conda install Jupyter, Conda install Jupyter Lab, Conda install Notebook, and get those things up and running there. Okay, and then lastly, this is optional, but I think one of the best IDEs available right now is Visual Studio Code, VS Code. Okay, and you don't have to use this. Jupyter Lab, I like Jupyter Lab a lot, and you can run Jupyter Lab on your machine as well. But VS Code is also really nice. So you can install VS Code. And so to do that, you'll go to code.visualstudio.com, and then you will download VS Code for your machine. Now, despite the name, Visual Studio Code is not the same thing as Visual Studio, okay? So Visual Studio is mostly for Windows and developing like kind of these .NET applications and things like that. And VS Code is, is based on open source technology and, allows for a bunch of kind of different extensions for different things. And so you'll go to download and you'll download for your system, whatever that might be, okay? All right, and so you'll get all of that installed and up and running. All right, so let me cut over to here. So let me just demonstrate a couple things. So in PowerShell, so I can check here. All right, so anyway, so you can run Jupyter Lab. All right, so this is one way. You can type in Jupyter space lab, and this will start up Jupyter Lab. It takes a little bit of time to get running, but it's basically going to start running a server, and then when I do that, it opens up a browser window, and okay, there it goes. All right, and so this is Jupyter Lab here running. Okay, if for whatever reason the browser window does not open, you will see as part of all of the output after running Jupyter Lab, you will see something right here. It says, to access the server, open this file in a browser or copy and paste one of these URLs. So, you'll just follow this instruction and you would just copy, and then, you open up a browser and you paste the URL into your address, and it will take you to the Jupyter Lab kind of server running on your machine here. And then from there, you can open up the notebook. Okay, so what you'll want to do is on your computer, from your terminal, I'm assuming you already, and again, if you don't have it set up, then just watch. But on your computer, you do git pull upstream main, synchronize those changes, and while you're in that directory, you'll call Jupyter Lab. Okay, you'll start Jupyter Lab, and it will start up inside your thing, and then you open it, and it will open up the Jupyter Notebook right here. Okay. The other option, again, is if you have VS Code installed, you can open up the directory somewhere on your computer, and then if you open up the .ipynb file, this is starting up, this is VS Code on my machine, and somehow I'm at the bottom here. It starts here. Oh, I have the wrong date here. It says week 1 Friday. Introduction to Jupyter and IPython, but this is where we will begin here. Okay. Yeah, sorry, I have the wrong date in here. Okay, but this is so you could run it either in VS Code or in Jupyter Lab. So I guess today I'll go through Jupyter Lab. Oh, actually, okay. One more thing you have to do in VS Code. So if you do install VS Code, you will need to install a couple extensions, okay? So there will probably be, on VS Code, on the left-hand side, there will be an extensions button. And you'll go to extensions, and the extensions that you'll need to install will be the Python extension, and then the Jupyter extensions, okay? And probably there will be Jupyter and Jupyter Keymap. I would say those would be the extensions you want. And then over here you'll have Python, all right? and then, it might also recommend a couple other things like the Python debugger and things like that. But basically, the ones you need will be Python, Jupyter, and the Jupyter Cleanup. Okay, and this will open up the notebook on your computer. Okay, so let's get into this. All right. So this is. Can you guys see that? Okay. Yeah.
The Visual Studio Code process is an alternative to having notebooks on Anaconda, right? Not something you need if you have Anaconda.
So we're still using notebooks. Okay, so notebook is, I guess, the file format, and how you open that notebook. You have a couple options. You can run Jupyter Lab, and you can open up your notebooks in Jupyter Lab, or you can have Visual Studio Code, and you can open up your notebooks in Visual Studio Code. Okay, so
It's like either or.
Or both. Okay, I mean not at the same time, but probably in this class, I'll some days I'll do it in Jupyter Lab, and other days I'll do it in Visual Studio Code. But yeah, that's something you can do. Okay. So here we go. Again, I apologize for the incorrect date there. And so we have Jupyter Lab, we have Jupyter Notebooks, a bunch of kind of ways to run it, and you have different IDEs like PyCharm. But yeah, we will take a look at right here. We'll look at Jupyter Lab or VS Code, and VS Code basically it runs very similar. So Jupyter, when you have a notebook, there's basically two modes that you can have. Okay, you have command mode and you have edit mode. Right, and this is going to be also true in VS Code. So everything I say here applies to both. In Jupyter Lab or in VS Code. Okay, so when you are in edit mode, it's going to look something like this. It's going to look, you're going to see the text be kind of monospace. It's like typewriter text, and it's going to look like you're editing code. Okay, and in here, I am editing basically a markdown cell. All right, and so this allows me to basically edit the text in here. Okay, and then whereas command mode, basically, I'm moving from cell to cell, okay? So you hit escape to enter command mode, and then you hit enter to go into edit mode. Now, when you're done if you're done editing the cell, you can hit this little button that says play, okay? And this will either run or render the cell. So in the case of code, it will run the cell. In the case of Markdown, where you're just having text, it's going to render it. Okay, and so you can hit the little play button. The keyboard shortcut is Shift-Enter, and so you'll see that after I hit Shift-Enter, it renders the text in there, okay, into basically formatted stuff. I think you guys are familiar with Markdown. But if you're not familiar with Markdown, basically you create headings using different kind of hash marks. One hash mark is a level 1 heading. 2 hash marks is a level 2 heading. 3, level 3, and so on. It basically makes the text bold and whatnot. You can have bulleted points by putting little, a little dash and things like that. And you can see, yeah, that makes my text bold. Creates bulleted lists. If you want something to look like monospace, you use backticks and things like that. Okay. Keyboard shortcuts, and this is something I strongly encourage, right, is don't use your touchpad or mouse, okay? Try to do as much as you can while you keep your hands on the home row of the keyboard, okay? So try to do as much as you can by keeping your hand on the keyboard and not using the touchpad. You will be much faster and much more efficient, okay? So to kind of add a cell, you can, while you are in command mode, you can type the letter A, okay? And that's going to add a cell above your current cell, okay? And I'm gonna hit escape, and then to delete a cell, you type D twice, okay? That deletes a cell. If you wanna add a cell below, you type B, okay? And that adds a cell below your current cell. And again, to get rid of this, I'm gonna hit D twice, right? And so that allows you to add cells and delete cells without moving, requiring you to use a touchpad. Otherwise, if you want to use your touchpad, you come over here to the menu bar, the toolbar, and you'll click Insert a Cell Below, and it does the same thing, okay? But I promise you, you'll get through. If you force yourself to use the keyboard shortcuts, you will learn them, and you will get much faster, okay? If you keep using the touchpad and you feel like, there's no reason for me to learn the keyboard shortcuts, you'll never learn the keyboard shortcuts, and you'll just be slow. Other things, okay? You can do cut, copy, paste, and for cut, copy, paste, you don't actually have to do Control X or Control C or Control V. You just hit like C, all right? So if I hit C, that copies the thing, and if I hit V, it pastes it, okay? And if I want to get rid of it, I can hit D, or I can just hit X to cut it, okay? And then to navigate, to kind of navigate between our cells, you can use J and K. J goes to the cells below, K moves to the cells above, okay? And I don't know if you have keyboard shortcuts enabled on Gmail, but if you do, it also uses J and K to kind of go up and down. And you might be like, why J and K? Why not arrow cells? Okay, the arrow keys work, but by using J and K, you don't have to move your hands off the home row. Okay, you can kind of leave them at the home row, and you can go up and down without having to move your hand down to the arrow keys. So it seems like a minor difference, but again, you'll get a lot faster just kind of keeping your hands on the home row and doing a whole bunch there. Okay, so J and K move up and down. Again, Jupyter, you have markdown cells. Everything we've seen so far have been markdown cells, and again, you put in text that you want displayed and whatnot in your markdown cell. You'll hit Shift Enter to kind of render it into some, kind of pretty print, and then but you can also have code cells, okay? And so a code cell, I think that's going to be kind of the default. So I can do something like 3 + 3, and that's going to if I hit Shift Enter, that's going to run it. Here I can go back into that cell, and I can hit M. M is going to change it to Markdown, okay? And so now it just gets rendered as text. If I want it to be code, I hit Y. Y is going to change it to a code cell, and then when I run it, then it's going to say, all right, this is code that I need to execute. If you want to do it kind of manually using your touchpad in the menu bar, you can change it from code to Markdown and back to code, okay? But again, use your keyboard shortcuts and learn them, okay? A little bit more on Markdown, some Markdown basics. Headings, they all start with the different hash marks, and as you increase the number of hash marks that you have, it's going to change, the size of your heading there, okay? If you're not too familiar with Markdown, you can learn a little bit more. So Jupyter uses Markdown. If you're in R and you have, if you're taking a class with me and I'm using R, I use R Markdown to kind of do my homework. And again, they all use Markdown. Okay. Bulleted list using dashes. You can put stars around your text to italicize, or 2 stars to make that text bold. You know what? I have forgotten. I have to give you your view quiz answer. Let me give you your first view quiz answer for today. It's the letter A. A as in apple is your first view quiz answer. You can also create math equations if you need to in Markdown. And in order to do that, you use $signs, okay? You use $2 signs to indicate that that you want to do some math equations, and and you'll basically use LaTeX. LaTeX as the form kind of language to put in math equations. And so if you wanted to write out like the PDF of the normal distribution, you could do that using, basically LaTeX formatting, / fraction for, 1 over sigma, square root 2 pi, so on and so forth. And you can produce mathematical equations this way, all right? So you have that. As far as running your cells, basically Shift-Enter is probably the command you're going to use. That's going to run the currently selected cell and then advance to the next cell. If you want to just run the cell but you don't want to advance to the next cell, you can hit Control-Enter. And then if you want to run the cell and then insert a cell immediately after it, you can also hit Option-Enter or Alt-Enter, and that will do that. Okay. All right, let's get into the very, very, very basics. And actually, let me clear all of the outputs here so you can see all of these things. And into just the very, very basics of Python. So Jupyter and I guess VS Code also, if you run these things, these will run. So all of these key maps also apply here. So here I am. Let me just go ahead and clear all of these outputs. They run IPython. IPython is kind of a interactive version of Python, which comes with a few nice little features. So here, if you run this cell, and if I say, hey, do 2 plus 3, okay, it executes that, and it says, that number is 5, okay? One kind of key thing to keep in mind is that in Jupyter, each cell is allowed to have basically only one output value, okay? There's a difference between values getting printed to the screen and the cell having an output value. So if I do something like 4 plus 5 and 5 times 5, only the last operation, which will be the 5 times 5, will be associated with the output value. So the output value is going to be 25, okay? I could put 4 plus 5 and 5 times 5 inside print operations, okay? And so this cell is going to execute print 4 plus 5. It's going to print 9 to the screen. It's going to execute print 5 times 5. It's going to print out 25 to the screen, okay? However, because I'm only just printing these values, they are not associated as an output value of the cell. And you'll notice there's a subtle difference here. You'll see here I've got a square bracket 2, okay, 25, indicating that the output value associated with cell 2 is 25. You'll notice there's no square bracket 3 here, okay, meaning there's no output value associated with cell 3, okay? Now we have seen that the values 9 and 25 get displayed. That's the print operation. The print operation displays things for you to see, but they are not output values, okay? It's, I'm trying to think what a analogy in real life could be, but it's just something being displayed versus like getting that thing returned to you, right? So it's kind of like, you go to the cash register and it says change due is like if you pay with cash, I don't know if you still pay with cash, but if you give them a 20 and you're supposed to get $8 back, on the screen it might say change due 8. That's kind of like the print, right? That's like something for you to be displayed. And then if you physically get that $8 back, that's the output value. And so here, there's no actual output value here. With IPython, basically all of the inputs and outputs that you get are kind of tracked and logged, and you can always kind of retrieve them, okay? So if you say, hey, what was the input in cell 1? You can say in square bracket 1, and it will tell you what you typed into cell 1. And it says what you typed into cell 1 was hash mark basic operations, a new line character, 2 plus 3. And that is exactly what I had typed in to cell number 1, okay? you could say, what was the output associated with cell number 2? The output associated with cell number 2 was the value 25. Okay. Out is what we call a dictionary. Okay. And you'll see there's no, we have an output for cell 1, an output for cell 2, an output for cell 4, which was this one here where we have basic operations. But there's no output for cell 3 because, again, cell number 3 doesn't have an output. Okay. And in is a list, and it just tells you this is everything that you've typed in so far into the different cells. Python has a couple slightly quirky features, and this will make sense later when we talk about iterables and things like that. But if you take a string like hello, you can actually do like a quote math operation with it. You can do 3 times that. And what it will do is it will take that string and it'll basically replicate it 3 times. And so here we will get one longer string, hello, hello, hello. Okay. If you take 2 strings, you can add them together. And so if you take hi plus goodbye, it just kind of concatenates the 2 strings together. And so we get just one string that says hi, goodbye. Within Jupyter, you can execute other scripts, okay? So here, I've created a very simple Python script, script01.python, okay? And I can open that up, and it's a script that contains just one line that says print hello world, okay? And I can execute this, and I can see, well, how does this run? So within Jupyter, if you want to run a script that exists in your folder, you will do %run, okay, and that will tell your computer to run this thing, and you'll do script01, the name of your script that you want, and it says, okay, well that script says to print hello world, and it prints hello world to your output here. Okay, let me open up script 2. Script 2 says print hello space and name, and print it's Friday again. Sorry for the wrong date here. Okay, and so here I'm gonna in my script I'm gonna in my notebook I'm gonna say my name is Miles. Name is equal to Miles. So I can define variables like this. Okay. Now if I try to run this script here, I'm gonna get an error. Okay. It says name is not defined. Okay, and that's because in this script, it's looking for this variable name, and that doesn't exist as far as the script is defined. Okay, here I've defined the variable name inside my notebook, and if I want to give that script access to the variables that exist in my notebook, I have to do run-i. Run-i will give when you execute the script, it will give access to the variables inside the notebook, and so here I can run that. And now it says hello Miles, and then it's Friday there. Okay. If you have shell commands, you can also run them. So for Mac users, you can see the contents of a file by calling cat. For Windows users, you can see the contents of a file by calling type. And so here I'm gonna, you precede kind of the shell command with an exclamation point, and so here it will just kind of run that shell command. So on my Windows machine, I'm going to do this. If you're on a Mac thing, then exclamation cat will run for you. Okay, and then at any time you can ask for help. You can call help print, and you will get the help there. Okay, let me. This is VS Code. Let me just kind of run these things as well. And so this is all operating the same. I think that's gonna, yeah. All right, so all of this also executes the same. And then if I call help print, same kind of output there. Okay, so just very briefly, we'll go just some very quick introduction to some Python syntax. Let me give you your second view quiz answer for today, which is the letter B. B as in bear. B is your second view quiz answer, B. Okay, comments are preceded by hash marks, okay? And so that's just a way to kind of write notes to yourself, and they are ignored. They are not run, okay? Lines, basically, enter. The end of a line terminates a statement. You don't need to insert a semicolon or something like from C++ or something like that. You can put in a semicolon if you want to run multiple statements on one line. You can do that. And then if you want to have a single statement cover multiple lines, you can escape it using a backslash, or you can kind of enclose the statement in parentheses. So here I've got two statements, x equal to 5, and then print x. That's what we have there. Here I've got three statements: y equal to 7, z equal to 7, or y equal to 6, z equal to 7, and print y plus z. And those statements get run. Here I've got this statement running across multiple lines by having a backslash there, okay? Or again, you can use parentheses to kind of enclose a statement across multiple lines, okay? And then if you have something here, I'm creating a list, and the list naturally just has an opening and a closing square bracket. And so here, as you know, this spans multiple lines, and it doesn't produce an error because it's just looking for the closing square bracket, okay? Another very important, I guess, feature of Python, and this is something that new users sometimes take a while to get used to, is that Python's code blocks are defined by indentation. So Python doesn't use curly braces or things like that to identify code blocks. They are identified using indentation. So if you have something like an if statement, okay, the way an if statement works is that it checks for the condition. If it's true, it runs the code block associated with the if statement. The code block is defined by indentation. So here I've got my first line is x is equal to 8, and then I have an if statement. I say if x is greater than 5, run the following statements. The statements that are associated with the if statement are those that are indented. Okay, and when you write an if statement in Jupyter, as soon as you hit colon, which kind of signifies the end of your if statement, Jupyter will automatically indent. The next line, and it will insert basically 4 spaces. Okay, and when you hit tab, there's kind of this debate of like tabs versus spaces. Basically, in Jupyter, when you hit tab on your keyboard, it's inserting 4 spaces. Okay, so you don't have to actually hit space 4 times on your keyboard or anything like that. Yeah, when you hit tab, it's going to insert 4 spaces, and you can see there are 4 spaces right there. And so the lines that are associated with this are, print x is greater than 5 and print x. Okay, whereas this line, print hello, is no longer indented, and so this print hello is not associated with the if statement. So when the if statement is true, here I have x is equal to 8. All 3 of these print statements are going to get executed. It's going to say x is greater than 5, x gets printed, and hello is going to get printed. Okay. Over here, I have x equal to 4. I've got the exact same code, and here I have x equal to 4. And in this case, because this statement is false, okay, these 2 indented statements are not going to be executed. Okay. So it's false. The associated code blocks, code is not executed, and so just print hello gets executed because the code block associated with the if statement will not run because it's false. Okay. This code cell and this code cell are very similar, but the key difference here is that print x is indented in this cell, and print x is not indented in this cell. Okay, and here, because print x is not indented, it is not associated with the if statement. So here, when I have x equal to 4, and I say if x is greater than 5, print this thing. Well, this is false, so this statement will not get printed. Okay. However, print x is going to run no matter what because it's not associated with the if statement, and then print hello. It will run no matter what because it's not associated with the if statement. So this is going to output 4 and hello, right? And so please, make sure you understand the difference between these two code cells. It's just the indentation which is going to change which lines of code get executed or are associated with if statements. And the same is going to be true for basically any kind of code blocks that you have in Python, whether it's a for loop or any kind of as you control the flow of your programming. So conditionals and loops and things like that. It's all going to be controlled using indentation. So no curly braces. Indentation is how it goes. It has the bonus effect, though, of making your code generally easier to read, because a lot of times, most style guides for other languages will recommend using indentation so you can kind of visually see these code blocks. But it's not enforced, right? You can have curly braces and you can have very poorly formatted code where nothing is indented, and that code is often very difficult to read. Because Python requires indentation to even define the code blocks, you're going to find that in general, Python code will be easier to read. Okay, that will be it for today's lecture. Again, if you have any trouble getting any of this stuff up and running, come by office hours. I'll have office hours today from 10:30 to 11:30, in person or via Zoom, and I can help you out. Let me give you your final view quiz answer, and so let me just go ahead and end the recording.